A review of last meeting. So we discussed how to transform any normal distribution to a standard normal distribution. So the reason is that we're going to use only one table in, let's say, finding area bounded by a normal distribution from a range of X values. All right. But we also discussed how to transform, let's say, standard normal distribution to the original normal distribution with a random variable X. So in this case, if you have a standard normal distribution, so your standard deviation must be equal to 1, and then the mean, which is the, in this case, center of our data, is z equal to 0. So keep in mind that this mu here is the mean of the z values. And in this case, mu equal to 5 is the mean of the X values. And your sigma here, which is sigma of the X values, standard deviation, is equal to 10. So when you use this formula here, so it is very important to understand that this mu and sigma here are the mu and sigma of your X values. All right. And also, if you're going to transform the standard normal distribution to the original normal distribution, then from this equation, you'll obtain this one, X equal to mu plus Z times sigma. So let's look at the first problem. So this is an application problem. Let's say an adult has an average, on average, of 5.2 liters of blood. So assume that the variable is normally distributed and has a standard deviation of 0.3. So let's find the percentage of people who have less than 5.4 liters of blood in their system. It's very important to draw the sketch of your normal distribution, okay, to easily picture the problem. Okay. So if you look at the given information, just to give you some tip here before you solve it, okay. So you're given the mean, okay, and it's clear that it is normally distributed, because if there's no information about the distribution of our random variable, if it doesn't say that it is normally distributed, then we cannot use our normal curve areas. So it is very important to know the shape of the distribution. In this case, we have a bell-shaped distribution, and standard deviation is equal to 0.3. So if we're going to draw the sketch of our distribution, in this case, we'll get something like this, okay? So this is your mean. It's the peak of your distribution, and the mean is equal to 5.2. And then you're looking for, find the percentage of people who have less than, okay, less than 5.4 liters of blood in their system, okay? So you're just looking for the area to the left of 5.4. So if we're going to standardize this distribution, what do we get? We get this distribution here, okay? You'll get, again, since the mean is equal to 5.2, so this mean becomes your z equal to 0, right? So that is using the formula, what? Okay, just use the formula in this case, z equal to x minus mu, and then all over sigma, okay? So all you need to find here is find the corresponding z value for x equal to 5.4. So this is equal to 5.4, and then your mu, in this case, it's equal to 5.2, and then all over 0.3. Okay. And I think that is approximately equal to, that is 0.2 over 0.3. So that is approximately equal to 0.67. So 0.67, let's look at our Z table here. So 0.67, So you have this one here, 0.6 and then 7, okay, which is equal to 0.2486. So if you're using our table in class, okay, then that means this area here, is equal to, so this region here is equal to 0.2486. So therefore, the answer to this problem is just, we know that the area to the left of 0 is 0.5. So our final answer is equal to zero point 0.5 plus 0.2486. So this is equal to 0.7486. In percentage, of course, this is equal to 74.86%. Okay. So let's say that to qualify for a police academy, candidates must score in the top 10% on a general abilities test. So we assume that the scores are normally distributed, and the test in this case has a mean of 200 and a standard deviation of 20. So let's find the lowest possible score to qualify for this police academy. So if we look at this one, you'll get something like this. Okay. So you know that the mean is equal to 200. Okay. And in this case, you find the lowest possible score to qualify. But in this case, candidates must be, as you can see here, candidates must score in the top 10%. So top 10%, that means that the score must be in this region, okay, where the area is 10%. So this is the top 10%. Since you're looking for the lowest score here, you're looking for the score of what? Okay, the value of your random variable x. It's not the random variable, standard random variable z. Okay, so how do we find this x value here? If you know the area to the right of this x value, which is equal to, we're interested for the x value. Of course, we solve this for x and we'll get something like x equal to sigma z and then plus mu, right? You solve for x in this equation and you'll get this one. So to find the x value, so keep in mind in this case, do we know already the standard deviation? Yes. Okay. Do we know already the mean? Yes. So all we need to find is the z value. All right. So let's find the z value. So in that case, you just draw your standard normal distribution in this case. So you need to find this z. Okay. So we're in the area of z greater than this z value here is equal to 0.10. But if we're going to use our table only gives the area between 0 and z. So if we're going to use the table, it only gives you this one, right? It's always the area between a z value and 0 or the area between negative z and 0. So if this area here is equal to 0.10, then what is the area of this red region? This will be 0.4 because we know that the area to the right of the mean, which is z equals 0, is equal to 0.5. So if we look at our table, we need to find the z value that will give us an area of 0.4. So let's go back to our table. So where is 0.4? So this is increasing, so it's not hard to find them. Okay, so let's have here, you have 0.4015 here and then 0.3997, which is closer to 0.4 in this case. Is it this one or this one? So as you can see, the closer value is this value here, which is 0.3997, because the difference between 0.4 and that one is only 0.0003. If you compare it with this one, the difference is 0.0015. So it is closer to this one. We don't have an exact 0.4 in our table, so we need to find the closest one. So what is the corresponding Z value here? So this is equal to what is this 1? So it is 1.2. So this is 1.2, 1.21, 22, 23, 24, 25, 26, 27, 28. Okay. So therefore, the Z value in this case is equal to 1.28. All right. So if you now find the X value here, you'll get X, which is equal to sigma. So let's go back to our sigma here. Okay. So our sigma is equal to 20, and then times 1.28, and then plus mu, which is equal to 200. Okay. So the answer for this one is equal to 225.6. So therefore, what is the cutoff score to enter this police academy? So the cutoff score should be around 226. So that is 225.6. So this is already cutoff score. So anybody scoring 225.6 or higher qualifies for that police academy.